Thanks Harald for the introduction and welcome to my talk about automated builds with GitLab and Unity. As Harald already said, I work at Huma Technologies and I work there in our Magic Lens team. Our Magic Lens is an AR app for visualization of industrial products and machines. It's made with Unity, obviously, and we currently support Windows, Android, and iOS. And we recently had a bigger project with a lot of machines and a lot of assets, and then we realized that we had to greatly improve our automated build pipeline. And during this task, I gathered some experience with that, and that's something I wanted to share with you. I think I will start with a few slides. Then in the middle of the presentation, there is a short or long demo. And at the end, I will continue with a few slides and I will give you some experiences of mine. Yeah. I don't know how many of you are worked with GitLab or have experience with GitLab, but yeah, just in case it's not everybody, let's ask, so what is GitLab? GitLab is an development operation platform, and there are self-hosted editions, and there are two editions. There's a community edition, it's open source, and there's also an enterprise edition with more proprietary features. And it has a ton of features. It has source code management, obviously, issue tracking, it's a Docker container registry. It supports Git large file system as a built-in wiki. And the thing I'm talking today about is the built-in CI/CD. So again, I think most of you will know what CI/CD is or have heard about the term CI/CD. But just in case, what is CI/CD? CI/CD stands for continuous integration, continuous delivery, and continuous deployment. The continuous integration part is the part where you automatically build your application or software or solution or whatever it is, run some unit tests, run integration tests, and the continuous delivery and the continuous deployment part, they are quite similar. It's a process of continuously having an released software for release. The difference is that in continuous delivery, you decide when to release your software. It's a more manual approach. And in continuous deployment, software gets released automatically. And it's said that in order to realize continuous deployment, you also need continuous delivery. So I have also a small graphic for you. I stole this from GitLab. And pointing doesn't work in an online presentation. So you see the CI part of the pipeline. So there you have your builds, your unit tests, your integration tests, and in the CD part there is your review cycles. You deploy it to your staging environment, and finally to the production. However, after reading a little bit into CI/CD, I realized I'm not at all an expert in this topic. It is huge, and I want to concentrate actually on the build part of the automated build part, or the CI pipeline scripting, and how you can do this with GitLab and Unity. So, what do we need to implement this? Yeah, obviously we need GitLab. Then we need a GitLab runner. Yeah, a Git repository which contains our project, and then we have to write a CI configuration. So let's start with the GitLab runner. So the GitLab runner is a service. You can install it on the server machine or whatever, and it executes jobs from the GitLab CI coordinator. There are versions available for Linux, macOS, and Windows, and it can execute all kinds of commands. It can execute shell commands, depending on the platform. If you're on Windows, it will either execute PowerShell commands or bash commands. I think it's called bash. Yeah. You can execute commands inside a Docker container. You can connect via SSH to a remote server and execute commands there. And you can also run concurrent jobs on one runner. But before you can use your GitLab runner, with GitLab, you have to register it. So you just call GitLab runner register, then provide it with the URL of your GitLab instance, and it needs a registration token. You get this registration token from GitLab. There are two kinds of runners. There are shared runners. Shared runners can be used by any project in GitLab, and then you can add runners specifically for just one project. To be able to register shared runners, you need to be a GitLab admin. And I think the most important part are the runner tags. So the runner tags are keywords you assign to your runner, which should describe the capabilities of the runner. So for example, if it has Unity installed, then give it a tag Unity, or more specific Unity 2019.3, or if it's a Mac OS runner and it has Xcode installed, give it a tag like Xcode or Xcode 10 or 11 if you want to be more specific. So now we have our runner registered. Now we want to configure our CI pipeline. And I wanted to do this with slides, but this is not so easy. So I thought it would be easier if I give you a short demonstration. So this is the part where with the CI demo. And I hope that everything works. So let's see. Where's my stuff? Okay. So let's get to GitLab. I have a GitLab instance running on my local computer. It runs inside a Docker container. And I've already prepared this CI demo project. So to add our CI configuration, we add a new file. That's the cool thing, you have an editor built in GitLab. And the default configuration file is .gitlab-ci.yml. And we start by adding a build stage. So just add my first stage in here. Then we can also add some variables. And then we add our first job that can be executed by our GitLab runner. So now I added a job called my job. It will be executed in the first stage. Maybe I adjust the camera here. It will be executed in my first stage. When always means that if the pipeline is created, this job will execute automatically. And this job will only be created or added to the pipeline if I push new commits. These tags correspond to the tags in the runner. So to be able to execute this job, there must be a runner who has at least those tags. I show you really quick. I have also on my computer a runner installed, a Windows runner, which is called my demo runner, and it has these 3 tags here. And if I commit this file, our first job we should create our first pipeline. Let's see if this works. Let's go to pipelines over here. And you see it's already running. This pipeline is running. You click on the pipeline, then you see the jobs. It's in my first stage. It's my first job. And here you see the execute hello is the job is executed. So let's have a closer look at the other tags, what this job is actually doing. So here in the script section, we write what we want to execute. Because it's a runner running on Windows and using PowerShell, this is the command, this is the syntax to access environment variables. And we define this environment variable over here. And the runner will set this variable for me. And I write just this variable in a file named hello text. So to be able to access this file afterwards, we'll create something like that's called an artifact. So an artifact is, in the artifact, I define which files I want to make persistent for the next stage. And in this case, I just added the hello text file. And you should always give an artifact an expiration date. Otherwise, you will fill up your drives. So let's get back to the job, and we see that there is an artifact available. So let's have a look at it, and it's my hello.txt file. And if I download it and open it, yeah, just as expected, hello. So let's go into the web IDE and extend this CI configuration by adding a second stage and also assigning a second job to this stage. So this is my oldest job. He will execute at the second stage. And this here means that this job depends on, this needs here means that this job depends on my job. This means he cannot execute before this job is successfully finished. Not only can I add variables on a global scope, or I can also add some variables here in a local scope. So that's what I did here. So this is my local variable. And when on success means, yeah, the previous job has to be successful. And I added the same tags. And as well, and as a new artifact, because I'm creating a result.txt file, and this is my final build result for this build job. And as you see, this is the syntax for just reading the content from the hello.txt, which will be created in the previous stage, and then writing my local variable in this result, and then this Gitlab variable, which I haven't yet defined, because this is another thing I want to show you. You cannot only provide variables or define variables in your CI file, you'll also be able to provide it directly via Gitlab. That's nice if you want to provide some encryption pass keys for some provisioning, signing identities or whatever. So let's call this Gitlab as well. So now we added this variable Gitlab, and it should now exist. And if I commit this file directly to the master, let's get back to our build pipeline. Okay. Okay. Here it is. So my first job is running, and if it's finished, let's refresh this page. Oh, my other job is running. And it executes the commands, and hopefully now it's finished. Now I should see my artifact over here. Browse my artifact. And where is it? Here. Hello world, hello Gitlab. So yeah, this was basically my hello world example. But what we actually wanted to do, we wanted to build a Gitlab project with the Gitlab CI, a Unity project with the Gitlab CI. So I have prepared a project as well. So I have to close some tabs. It's getting really slow. Okay, no. So I also already prepared a Unity demo project. And I think I will show you the demo project first. By the way, this repository over here, I will give you the link to this repository so you can have a look at it. And there's also some Docker Compose files and Docker files in there, so you can run Gitlab by yourself and can install the run and can have a and can try it yourself, because this will a little bit. This is a little bit much for this amount of time that I have available. So I have a empty GitLab project, and it just has these text area over here. And if I click play, it has some. It prints out some job ID, pipeline ID, commit reference, commit message, commit hash, and a backend base URL. So, and the script over here just loads my settings object from the resources, and this setting file is over here in my resources, and it has all these fields. My goal is that when you release a software or deploy a software, and there are some, you always want to know if there are errors. You want to know which version you're dealing with. When was this version built? At which commit? And also you want to be able, like here with the backend base URL, to build different versions for different environments. So we have to provide this information from outside, and therefore we write. I write a small build script in Unity. It's just a class. It should be in inside. It should be in an editor folder, and there I added a static method, which is called my build process. And the first thing it does, it just loads these settings file, reads the environment variables we will provide, and writes it into the asset, and then saves the asset back. And as you see, there are some environment variables with this CI prefix, and those variables are provided by Gitlab. So, and there are a ton of them, and there is a documentation, and you can read into and use the ones you need. And not only can you write these settings in your own settings object, you can use this information, for example, to say to set the player bundle version to the commit tag or whatever. This is up to you. This is just an example. Then we also use the provided information to create our output path, and then we just call build pipeline player build with the provided information. So when we do this using the runner, Unity will be executed in the batch mode. So that means we have to check here if it's in the batch mode, and if it's in the batch mode, we want to exit the player after the build is finished. And we want to give the Unity runner a feedback if this process exited successfully or if there were errors. And typically, if everything is fine, a process returns 0, and otherwise something else than 0. And we don't just check here, are there any errors? And if there are, then we return 1, otherwise we return 0. So now we have our build script inside Unity. Now we have to integrate it in our CI configuration somehow. So what I did over there is I used Node.js for building the project. And not only Node.js, there is Gulp.js is actually made for front-end developers, but it's quite nice. It has a few nice features, and you can define your tasks over here. And I just defined 2 simple tasks: find Unity and build Unity. So find Unity looks in the local runner for a suitable Unity installation. So, oh, actually, sorry, I'm on the wrong method here. Yeah. So we provide an environment variable Unity version. This is the Unity version we want to build it with, and then the path to our Unity Hub path. So why Unity Hub? Because Unity Hub added a CLI support, so you can list or install or whatever new Unity versions using command line interface, and that's what we did. I mean, it's not perfect, but it works. So we just search for the Unity Hub path, and with this few command arguments, it will give you a list of all the installed Unity versions. And yeah, with a little string trickery, you will get the path and save the path. The next step is now we have the path to our Unity editor. We execute our build process using the Unity editor CLI. So we call it with the argument batch mode. That means that the editor won't open the UI window and just runs in batch mode, literally. Then silent crashes, that means that if something terrific happens, it won't open a crash report window. Log file, you can add the location of a log file over here. If you just enter a dash, it will log everything to standard out. The current project path, but this is similar to our current working directory. Here the cache sub IP, I will come on that later. And the build target, which we want to build. Currently, there's only Windows 46 or Windows. And the method we want to execute, and this corresponds to the method in my build script. So now we have our simple build script. Let's have a look at the CI file. It has only one stage, and it will output it in the output directory of our build is called build. The build prefix will be demo, and we build it with the this Unity version. Why specifically this Unity version? Because I had it installed and I was too lazy to install a different one. And because we use Node.js to build this, we have to install the packages before, and there is this default job, and this before script will be executed before any other script. Also, if you're wondering where, because over here we had this Unity Hub path variable, and if you're wondering why this is missing over here, this is actually configured in the runner's configuration, because this is part of the runner's environment, and this is the runner's configuration, and I added this variable over here. So because Unity Hub could be installed on a different path on every other runner. Yeah? So then finally I have created two jobs over here, the production job and the development job. And they are actually quite similar. The only difference is that the production job has the backend base URL of production my domain at my game or whatever, and the development will point to our development environment. The build result of both will be uploaded as an artifact. And one more thing, I haven't shown you this, and this is actually really, really important. You can cache certain folders on your runner, and this is a push-pull cache. Yeah. You can also define if it should pull the cache or only push the cache, but if you per default it's pull push, and that means that before the runner will execute a script, and after it has checked out all the repository, it will look for a cache named Windows. This is on a project scope, and pull this cache in. And the cache folder we want to cache is the library folder, because when you open up a new Unity project with a lot of assets, Unity has to import all these assets and convert it for a specific platform. And the runner would have to do this every time, and you don't want to do this. So with this cache, the first job might take longer, but after that, would increase your build speed, because after this job successfully succeeds, it will cache the job locally. So now let's see if this works actually. So yeah, sorry, one more thing. I configured the jobs differently, because here I have that this job will only be created on a tag, and this will be created on a push, and it should also be created when I tag. So let's create a new version over here. Let's go to tags and add a new tag. 0.0. I think it should be 13. Create a tag. Go to our pipelines. And you see one of the jobs is already running. The other is a manual, so it's start both. And as you can see, both of these jobs run concurrently with one runner. This is because I've set the concurrency value here to 2. So let's wait. So both of them are currently checking out the project. Here you have restoring cache. That's what I told you recently. Checking for cache windows. Yeah, that's the point. Because I already tried this many times during my rehearsal. So and it's not a big project though, so it should just take only 1 or 2 minutes. I hope. Okay, yeah. Now it will execute the before script. Maybe we can do this here side by side. So it's the wrong window. This one. So we see what's going on. So it's currently at this point executing the script. Yeah, and now it executes build windows. And you see that all of this is the Unity's log output. So we executed Unity in batch mode, and it will build our project. Oh, come on. Last time I tried it, I thought it was faster, but oh, hey, it's done already. So yeah, now it pushes the cache back and uploads the artifact over here. Job succeeded. And let's see. We have our artifact here. Let's download this one. This is our production job. Now over here, we have it's also succeeded. We have our development job. Let's open those. So extract both of those here. And if I open the development job, you see this, I added the right version tag over here. Just open it. And yeah, the backend base URL points to develop. I have my hash over here. I have my updated readme. This was my last commit, and my commit reference is actually the tag. Those the pipeline number and the job ID. And let's get back to my production job. Open it up. Yeah, different job ID, same pipeline ID, same tag, same commit message, and a different, production, sorry. And a different backend base URL. So you can build multiple versions with multiple configurations at the same time. So I think this concludes my little demo. You can have a look at it by yourself. I will, as I said, I will provide you with the the repository. So let's continue. Now, in the last part of this talk, I want to, as I said, I want to give you some tips and share some experiences with you. And I want to start with iOS builds. So something I didn't know for a long time was that you can create Xcode projects on a with a Windows editor, and you can build them on a Mac OS. So you still need to build it on a Mac OS, but you can create the Xcode project on Windows. The only thing you probably have to do is because when the project is created on a Windows runner and transferred to the Mac runner as an artifact, because it was created on an NTFS file system and then transferred to the Apple file system. I think it's called APFS. There are sometimes some shell scripts inside the Xcode project, and you have to add the execute permission to this shell script. Otherwise, the build will fail. And the benefit of this is that you can use cheap Mac minis as Xcode runners. And I know cheap is, when it comes to Apple, nothing is cheap. The cheapest one is €1,000, but you will get probably a cheap one from Willhaben with €400 or €500, and it is more enough for the Xcode build, because the Xcode build doesn't take that long normally. The only downside, if you want to use the burst compiler in Unity's new DOTS, you have to build the Xcode project on a Mac, and not build the Xcode, create the Xcode project on the Mac. So that brings me to the next slide, runner and hardware. That should mean runner hardware, but I forget to change it. Doesn't matter. In my opinion, it's better to use a few powerful runner machines instead of many cheap runner machines, because you can put in a powerful SSD, a multi-core CPU, and a lot of RAM. And then you can increase the concurrency of the runner. And this will increase your license cost, because for each runner that has Unity installed, you have to pay a seat. And I think one seat is about 100 euros a month, and this is 1,200 euros per runner. And yeah, this is the tip for the hardware. And next, my next tip is actually for asset processing. At a certain point, you will write some pre-processing scripts to, I don't know, scale down some textures, or process some of your meshes, enable mesh optimizer, whatever. Or I can give you an example. We had the problem, we wanted to create a shader variant collection for all our assets in our project. And we had a script that ran over all our asset bundles and collected all the assets, and then collected all its dependencies, and created this shader variant collection by collecting all the materials. this was actually fine for smaller projects, but when we got a bigger project, when the project grew bigger and had more and more assets, what happened is that Unity actually loaded all the assets into the memory, and the memory footprint exploded. We went up to 16, 20 gigabytes, and then we had to decrease the concurrency on one of our runners. Otherwise, he wouldn't be able to build the project. So it is very important to keep a low memory footprint, even in your editor scripts. And you can use this by using the asset paths instead of the actual objects when you want to pass objects between some functions. Just pass the path and then load the asset in this function when you need it, and then unload it. You can also use the unload unused asset immediate function, but you have to be careful with that because, for example, if you load an asset, which is, for example, a scriptable object like my settings asset, then call this function and try to access anything on this object after you call this function. This object is deleted, and you will get then an exception. So be careful with that. So, and let's get to my last advice. Also, tip is how you can reduce your asset import time if you don't use Unity Teams. And I think there are 3 simple steps, and they all have to work together. So you should always use the same Unity version in your team, and don't use different versions. The next thing is, and this does not work for everybody because developers have to switch platforms, but you should actually select the same platform. So if you say everybody works with iOS selected or with Windows selected, especially the ones who creating assets or adding a lot of assets. So the artists should select the same platform. And the third step is to use the Unity cache server. And the Unity cache server is a service, it's also for free. And you can install it somewhere in your intranet on some machine or on a network attached storage that supports something like this. And just enter it in your player preferences, enter the domain name, IP, and port or whatever. And what this Unity cache server does is every time you add a new asset to your project, it will check at the cache server if there is already a converted object based on the input asset, the platform that was selected, and the importer version. That's why it's also important to all use the same Unity version. And if there is an asset in the there's a converted asset entry, a cache entry at the cache server will download this asset. And if not, you have to convert it on your local system, and then the cache server will upload it and you will upload it to the cache server. And the benefit if your colleague came back after his vacation and checks out the last changes of the repository, a lot of the assets will be already converted on the cache server, and he just downloads these assets and does not have to convert it. And this will also increase your build speed, because as I just said, I will come back to this. Where was it? Over here. I added the cache server also to the build process. So during the build, it will use the same cache server. So the initial Unity does not have to convert the assets initially, so it can also download the new changes when you trigger a new build from the cache server. The only downside, it does not cache shaders. Yeah, but anyways, this will greatly increase your build time and your overall reduce your overall import time. yeah, and this was my last tip. And as promised, this is the URL to the repo, and you can have a look at it. And I think I'm open for question right now. So.
Yeah, thanks, Armin, for this awesome talk. It was mind blowing.
Yeah, mind blowing.
No,
Thanks,
really.
guys.
Really. I mean, we do also a lot of command line stuff. We had it in the last talk also, but this is really head up. That's really a masterpiece, I would say.
Thanks, guys.
I always was curious what CI/CD means in Gitlab. I thought it was like corporate identity stuff or something like that. I never looked it up. I was not, I was not aware that it's such a powerful tool. It's really, really nice. Awesome talk. So guys, anybody, questions?
There were no questions on the chat, so
not yet. Yes, but maybe they pop up.
Yeah. Feel free to unmute yourself, and
if there are no questions, I have one question regarding if you run Unity, if you run the runner on GitLab, has it to be everything on the same machine, or can you distribute it on different machines?
Yeah, of course. This is just for my demonstration purpose. I can show you what actually happens. Let's see. Oh yeah, I have everything in the same repository, so it is easy to test it. So you can install the runner on a different machine, distributed somewhere. Yeah. And what actually happens, and also why it is able to run 2 Unity instances on the same project, is when can you see this here? Yeah. Maybe I opened it. Yeah. This is the runners directory, and it will create this builds directory. And inside there is for every job he can concurrently execute, there's a 0, there's a 1. If I would increase it to 3, it could there would be another folder. And then I have over here I have the group, and here I have my Unity demo. So it really checks out the project twice. But as you know, it's not possible to open the same project with Unity twice. So the project is really checked out twice on your machine, and the runner is completely independent from you from GitLab. So it can be anywhere. Does that answer the question, or did I answer it?
That's awesome. This also clarifies my second question, which was like how the push-pull cache is working when you have 2 different versions of the same project, but you just
yeah, push-pull caches work. He caches locally. You have here this cache zip file, and it's for in this cache zip file. If I open it, I think I open it in the browser within Explorer. You see that this is actually the library folder of Unity inside this. And this is on a project base. So if you add a different project and it has the same cache name, the runner will create a different cache folder. It will create a different cache folder for each project, but inside the project in different jobs you can share caches with these cache name. And also, if you run into some problems with the caches, if you go over here to pipelines, you can here clear the runner caches for this particular project, and it will delete them.
Okay, there's a question from Jan, who is asking if you have tried distribution as well, especially regarding iOS certificates.
We have it implemented at UMI, but because I don't have you mean iOS distribution or with
I think
the
so.
runner?
Jan, would you like to ask the question?
You mean uploading the application to the App Store, or?
I assume iOS is difficult because of the certificates, but locally in your network for Windows devices and Android.
Pardon? Sorry, I didn't understand that.
So that you push the apps or the artifacts directly to the devices?
Ah.
No, you have to download it. I think the artifacts are. It's not meant that you download the artifacts from there manually. You can do this for if you have your development builds and then install it manually, but you can also script this in your CI pipelines. If you, for example, has a wall of devices and test devices and they're connected somewhere, you can script a new build stage that just is deployed to test devices, and then do it by however you like. You know? But the artifacts are actually used to transfer build byproducts from one stage to the next stage. Mm-hmm.
I think you can command line Xcode too, but it's a little mess. I think you can command line Xcode too to deploy it directly.
I didn't understand the question correctly. Yes, this works. We do this. And at UMI, we have one build stage for Unity. It creates the Xcode project, and the Xcode project will be uploaded as an artifact to GitLab. And the next stage is running on a macOS runner, and there we build the Xcode project and then upload it to different deployment targets. There is our Composer platform where the app is uploaded, so our customers can download it from there because we sign it with an enterprise certificate. And also there is our internal network attached storage where we upload the app so we can look at it and download it internally. So this is really up to you, but it is possible to build and sign the app in Xcode using the runner and with command line. But it's a lot of work to figure it out, though.
There is a tool called Fastlane, which makes it a little bit easier to sign.
Ah, okay.
And
Fastlane.
Fastlane, yeah.
Okay, I have to Google that.
Then you can create the screenshots and upload it to the App Store. Yeah.
Cool. Yeah, for us, it's that we have apps that are not always signed for the app stores, but they are signed with an enterprise certificate for self-distribution, in-house distribution.
Yeah.
Mm-hmm.
Yeah, especially with the code signing, it helps because you can share the keys in your team, so you avoid to be dependent on the one person with the one key on one machine.
Is this a tool you can self-host, or is this a cloud service? This Fastlane?
It's actually just a command line tool, and
cool.
It encrypts the key and stores it. You can store it on any Git repository for sharing the keys.
Thanks for the advice. This is really nice.
Yeah. Are there more questions to Armin about his great talk?
I had one, but I forgot it. One thing I wanted to mention: you can always build asset bundles without a license. There is no license needed. If we do a lot with asset bundles, especially like contents, and you can kind of trick Unity there.
You mean you can build asset bundles, but you don't need a seed to use Unity, even if you build just asset bundles. I'm not sure about that. Really?
No, you don't need a license for Unity for building
to build asset bundles.
Exactly.
Okay, you just need the license only to build the player. Yeah,
exactly.
I mean, we did do both, so yeah, we have to pay the license anyways.
Yeah, that's true. We do, but you can, let's say you can run asset bundles on a cheap standalone machine or whatever, so you don't have to care about licenses there.
Oh, okay, yeah.
We have a lot of them. Yeah.
So when you scale, you have like two runners, two machines with a full Unity license to build the actual app, but maybe three more for just building the asset bundles or something like that.
Cheaper ones for the asset bundles, yes, yeah. Wow, cool. Yeah. I mean, you can also do one thing, and you can cache the asset bundles as well. So that's also the thing we did. We cache the asset bundles because when you create new asset bundles, or when you build your asset bundles, Unity will check if the asset bundle hash, if the asset bundle hash will change, if there is something to do, and only creates the asset bundles that have changed. So if you cache the asset bundles as well, you will also speed up your build process.
A question came back into my mind. So how many scripts are involved in the process? I saw a lot of them, like 4, 5, 6.
For this particular demo, let me see. And there's just in Unity, it's actually just the my settings. It's just a script table object. Then the demo script is just to print out the stuff on the scene view, and the build script over here, and over here we have, where is it? The gulp.js file.
Yeah.
And it has 2 scripts. It's the find method where you can find your Unity version, build your Unity version. And this is not really a script. This is actually the CI configuration. So it's about 4 plus the CI configuration.
Yep. But do you also put them in the repository or something? Because I think you can, or somebody can easily mess up the script, and then the whole chain breaks down.
These scripts?
Yeah,
because we not only have one application, we have multiple. This is in a separate repository, and this is added as a submodule. And in this submodule, there is the build script. So I don't have I have the path. Like you can add the path from Scout to the file. You can set F, and this is my submodule, and build script, and tell him where the Gulp file is, and execute it over this way. And what something else you can do. You can also, there's something else we did, because you don't want to add all this stuff in every repository where you use this. You can include templates for your CI file, and then you can extend jobs. So that you can write most of this stuff in a separate file, and then say .extend and just assign the stages and when do you want to execute it. So it's less configuration effort.
That's cool.
And